Troubleshooting steps to resolve a 347 volts lighting system tripping a substation breaker involves a systematic approach. Firstly, verify the load balance. Ensure that the load is evenly distributed across all three phases. Use an ammeter to check the current draw on each leg of the lighting panel. The current reading should be roughly equal across all phases. Significant imbalances can cause nuisance tripping of the ground fault breaker. Secondly, inspect the neutral connections. Verify that the neutral connection at both the lighting panel and the substation is secure and tight. Loose neutral connections can create a high resistance path, leading to voltage fluctuations and overcurrent conditions that can trip the breaker. Pay close attention to the torque specifications of the neutral connections and use a calibrated torque wrench to ensure proper tightening. Thirdly, check for insulation defects. Use a megameter, also known as a mega, to test the insulation resistance between the conductors and ground. Disconnect the power to the lighting circuits before performing this test. Apply the appropriate voltage from the megameter, typically 500 volts or 1000 volts, and measure the resistance. Look for any readings below 10 megohms, which indicates a potential insulation defect. Investigate any low resistance readings to identify and repair the insulation fault. Fourthly, examine the pulse start ballasts. Pulse start metal halide ballasts are known for generating high inrush currents when starting up. These inrush currents can briefly exceed the breaker's instantaneous trip threshold, causing it to trip. Check the specifications of the ballasts to determine their inrush current characteristics and ensure that they are compatible with the lighting panel and substation breaker. Consider the inrush current rating of the breaker and compare it to the total inrush current of all the ballasts in the circuit. Fifthly, test for harmonic distortion. Use a power quality analyzer to measure the harmonic distortion on the lighting circuit. Harmonic distortion is the presence of currents and voltages at frequencies that are multiples of the fundamental frequency, typically 60 Hz. High harmonic distortion can overheat transformers, breakers, and conductors, leading to premature failure and nuisance tripping. The total harmonic distortion, or THD, should be within acceptable limits, typically less than 5% for voltage and less than 20% for current. If the harmonic distortion is excessive, consider installing harmonic filters to mitigate the problem. Sixthly, monitor the voltage. Use a data logger to monitor the voltage at the lighting panel and the substation over an extended period. Look for voltage fluctuations, sags, or spikes that could be contributing to the breaker tripping. Voltage variations outside of the acceptable range can stress electrical equipment and cause malfunctions. Review the voltage data to identify any patterns or anomalies that may be related to the breaker tripping events. Now let's move on to potential solutions to this issue. Firstly, consider adding current limiting reactors, also known as CLR. Install CLR on each lighting circuit to reduce the inrush current when the lamps start up. CLR are inductive devices that limit the rate of change of current, effectively reducing the peak inrush current. This can prevent the breaker from tripping due to the high inrush current associated with pulse start metal halide ballasts. Select CLR with appropriate impedance values to achieve the desired current limiting effect. Secondly, consider using soft start ballasts. Replace the existing pulse start ballast with soft start ballasts, which gradually increase the current draw when starting the lamps. Soft start ballasts use electronic circuitry to control the inrush current, reducing the stress in the breaker. This technology can significantly reduce the likelihood of nuisance tripping. Ensure that the soft start ballasts are compatible with the existing lighting fixtures and electrical system. Thirdly, install transient voltage suppressors, also known as TVS. TVS can be installed to protect the lighting circuits from voltage spikes and transients that could cause breaker trips. TVS are devices that clamp the voltage to a safe level, diverting excess energy away from sensitive equipment. Install TVS at the lighting panel and at critical points in the lighting circuits to provide comprehensive protection. Select TVS with appropriate voltage and current ratings for the application. Fourthly, reduce the load if possible. If feasible, reduce the number of lamps on each lighting circuit or install additional lighting circuits to distribute the load more evenly. This can reduce the overall current draw and the potential for breaker tripping. Consider reconfiguring the lighting circuits to balance the load across all three phases. Fifthly, use a different breaker. Consider using a breaker with a higher interrupt rating or a different trip curve to better accommodate the inrush current from the lighting circuits. A breaker with a higher interrupt rating can withstand larger fault currents without tripping. A breaker with a different trip curve, such as a time delay breaker, can tolerate brief overloads without tripping, allowing the lamps to start up without interrupting the circuit. Consult with a qualified electrical engineer to select the appropriate breaker for the application. Another aspect to consider is the type of ground fault protection being used. Ground fault breakers are designed to trip when they detect an imbalance in current between the hot and neutral conductors, indicating that current is flowing through an unintended path to ground. There are different types of ground fault protection, including ground fault circuit interrupters, or GFCIs, and ground fault equipment protection, or GFEP. GFCIs are typically used in residential and commercial applications to protect people from electric shock, while GFEP is used in industrial applications to protect equipment from damage. The sensitivity of the ground fault protection can be adjusted to reduce the likelihood of nuisance tripping. However, it is important to ensure that the ground fault protection is still effective in protecting against ground faults. You could also review the panel bonding and grounding. Proper bonding and grounding are essential for ensuring the safety and reliability of electrical systems. Bonding refers to the practice of connecting all metallic parts of the electrical system together to create a low-impedance path for fault current. Grounding refers to the practice of connecting the electrical system to earth to provide a reference point for voltage and to facilitate the flow of fault current. Ensure that the lighting panel is properly bonded to the building's grounding system and that all grounding connections are tight and secure. Check the grounding electrode system to ensure that it is properly installed and maintained. Improper bonding and grounding can create ground loops and increase the risk of electric shock and equipment damage. Surge protection is also crucial. Lighting strikes and other transient voltage surges can damage electrical equipment and cause breaker trips. Install surge protection devices, or SPDs, at the service entrance and at the lighting panel to protect the electrical system from surge voltages. SPD diverts surge current to ground, preventing it from damaging sensitive equipment. Select SPD with appropriate voltage and current ratings for the application. Harmonic filters were touched on earlier, but let's dive deeper into them. Harmonic filters are used to reduce the level of harmonic distortion in electrical systems. Harmonic distortion can cause a variety of problems, including overheating of transformers and conductors, increased energy losses, and malfunction of sensitive equipment. Harmonic filters are typically installed at the source of the harmonic distortion, such as the lighting panel. There are different types of harmonic filters, including passive filters and active filters. Passive filters use inductors and capacitors to filter out specific harmonic frequencies, while active filters use electronic circuitry to actively cancel out harmonic currents. Select the appropriate type of harmonic filter for the specific application. Also make sure the panel schedule is up to date. An accurate and up-to-date panel schedule is essential for troubleshooting electrical problems. The panel schedule should list all of the circuits in the lighting panel along with their corresponding breaker numbers and the loads that they serve. This information can be used to quickly identify the circuits that are causing the breaker to trip. Verify that the panel schedule is accurate and that it reflects the current configuration of the electrical system. Furthermore, make sure the equipment is properly ventilated. Overheating can cause breakers to trip and can damage electrical equipment. Ensure that the lighting panel and other electrical equipment are properly ventilated to prevent overheating. Avoid blocking ventilation openings and ensure that there is adequate airflow around the equipment. If necessary, install additional ventilation fans to improve airflow. When you installed the new lighting system, did you perform infrared scanning? Infrared scanning, also known as thermography, is a non-destructive testing technique that can be used to identify hotspots in electrical systems. Hotspots are areas of abnormally high temperature that can indicate loose connections, overloaded circuits, or failing equipment. Perform an infrared scan of the lighting panel and the lighting circuits to identify any hot spots. Investigate any hot spots to determine the cause and take corrective action. Use a thermal imaging camera to capture images of the equipment and analyze the temperature distribution. Are the ballasts you installed energy efficient? Energy efficient ballasts can reduce the overall energy consumption of the lighting system. Replace the existing ballasts with energy efficient ballasts to save energy and reduce operating costs. Energy efficient ballasts typically have lower harmonic distortion and lower inrush current than traditional ballasts. Look for ballasts that are certified by a recognized energy efficiency program such as Energy Star. What about power factor correction? Power factor is a measure of how effectively electrical power is being used. A low power factor indicates that a significant portion of the current is not being used to do useful work. This can result in increased energy losses and reduced capacity of the electrical system. Install power factor correction capacitors to improve the power factor of the lighting system. Power factor correction capacitors reduce the amount of reactive current flowing through the system, improving the overall efficiency. The conductors and conduit need to be sized properly. Undersized conductors and conduit can overheat and cause breaker trips. Verify that the conductors and conduit are properly sized for the load that they serve. Refer to the National Electrical Code, NEC, or other applicable electrical codes to determine the appropriate conductor and conduit sizes. Consider the ampacity of the conductors, the voltage drop, and the ambient temperature when selecting conductor sizes. Has there been voltage drop? Excessive voltage drop can cause lights to dim and can damage electrical equipment. Measure the voltage at the lighting fixtures and at the lighting panel to determine the voltage drop. If the voltage drop is excessive, increase the size of the conductors or reduce the length of the circuit. Refer to the NEC or other applicable electrical codes for voltage drop limits. Is there proper coordination of the overcurrent protection? Proper coordination of overcurrent protection is essential for ensuring that only the faulted circuit is de-energized during a fault condition. Overcurrent protection devices, such as breakers and fuses, should be coordinated so that the device closest to the fault trips first, minimizing the impact on the rest of the electrical system. Perform a coordination study to verify that the overcurrent protection devices are properly coordinated. Is there proper labeling of the equipment? Proper labeling of electrical equipment is essential for safety and troubleshooting. Label all of the breakers in the lighting panel with the circuits that they serve. Label all of the lighting fixtures with their voltage and wattage ratings. Label all of the disconnect switches with their function. Use clear and durable labels that are easy to read. Did you perform a maintenance on the lighting system? Regular maintenance is essential for ensuring the reliability and safety of electrical systems. Perform regular inspections of the lighting system to identify any potential problems. Check for loose connections, damaged insulation, and other signs of wear and tear. Clean the lighting fixtures and replace any burned-out lamps. Test the breakers and other overcurrent protection devices to verify that they are functioning properly. Keep records of all maintenance activities. You might want to look at the ambient temperature. High ambient temperatures can reduce the ampacity of conductors and can cause breakers to trip. Ensure that the lighting panel and other electrical equipment are located in a well-ventilated area and that the ambient temperature is within the acceptable range. If necessary, install additional cooling equipment to maintain the ambient temperature within the specified limits. Finally, I recommend consulting with a qualified electrician or electrical engineer. Troubleshooting electrical problems can be complex and dangerous. If you are not comfortable working with electricity, consult with a qualified electrician or electrical engineer. A qualified professional can help you identify the cause of the breaker tripping and recommend appropriate solutions. They can also perform electrical testing and inspections to ensure that the electrical system is safe and reliable. They will be knowledgeable about the applicable electrical codes and standards and can ensure that the electrical system is in compliance.